Part 2, keeping track at home. I'm sorry. Nick, number 2. Number 2. What do we need to know for number 2? A cube 10 centimeters on edge can hold 1 liter of water. A foot is about 30 centimeters. Oh, look at that.
Hi, surprise.
Get a couple good ones. They should have makeup say, you want them looking at the, like they're studying.
Yeah,
Doesn't
study.
happen. Otherwise you get that same patented little thing there.
That'll be a good one.
That would be Lucas, who should have his math out on math. Certainly engrossed in his club. Alright, for problem number 2, children, here again is what you need to know. The problem is you're changing cubic centimeters into liters, okay? And the basic gist of this, boils down to this, okay? 1,000 cubic centimeters is the same thing as 1 liter. Okay, for the reason that 1 cubic centimeter equals 1 milliliter. 1 cubic centimeter is 1 gram, it is also 1 milliliter. Okay, you go to the hospital, and you get an IV, they will say how many cc's is what they say. Give them 10 cc's of whatever, that's 10 cubic centimeters, which is the same as 10 milliliters. Okay, but you need to know just that this is this. So this thing is the 10 by 10 by 10 cubes, so it is 1,000, I don't know why I always have the stuff I do, cubic centimeters, which means this is 1 liter. Okay, that's what they said here. Now this again goes back to the scale factor thing. Okay, you do not now have a 10 centimeter on edge one, you have one that is 30 centimeters. And you don't even really need to draw it, but you can if you want. What's the scale factor from 10 to 30? 30 times 3, it's 3 times bigger. Okay, so if the scale factor is 3, okay, the volume is going to be 3 cubed times bigger, because you take the scale factor and cube it. And that's where 3 times 3 times 3. The new one is going to be 27 times bigger volume-wise than the old one. And this one was 1 liter, so if this is 27 times 1 liter bigger, it is actually 27 liters, because it's 27 times bigger. 1 liter, 27 times bigger is 27 liters. Okay.
So, 27, you got it
Because the scale factor was 3. And to find volume between things, you take the scale factor and cube the scale factor. You don't cube this, you just cube the scale factor. Whatever the scale factor says it is, you cube that. Nathaniel Lichtenstein. I can do number 4. Number 4 simply asks you the probability of drawing both red marbles. That's really what they're asking. If you look at the bag, you have 3 reds, right? And you have 6 blues. It's going to be a little tough to tell based on my V here. Okay, so Nathaniel, the probability of picking the first red one, how many red ones are there? 3 out of how many total marbles? 9. Now, when you've taken that one out, and this one's gone now, how many red marbles are left? And how many total marbles? 8. The probability of both of those happens are their probabilities multiplied together. You do a little cross canceling here. This is the same as 1/3. This is the same as 1/4. You end up with 1/12. Nick,
Can you do number 16?
I would love to do number 16. Oh, 16 shouldn't be so bad. Did you draw the rectangle, Nick? You got your rectangle here, correct? It has a length of 2x minus 1 and a width of x plus 3. How do you find the area of a rectangle? Area equals length times width. So you're just going to take x plus 3 and multiply it by 2x minus 1. And that is a binomial times a binomial, which is FOIL. The two first terms give you 2x squared. The outside term is a negative 1x that combines with an inside term of a plus 6x to give you 5x's. And the last term in FOIL is negative 1 times 3, which is a negative 3. And that's where that whole thing comes from. Brandon, are you jotting down any of this note stuff here, or is this all just get stuck up there in photographic memory? What? What's that?
I already have.
You have those exact notes and you did that problem just like that? Huh? What do you say now?
No, I have.
Well, I'm just saying. See, as I look about here, I've got people who are diligently scribbling stuff at every possible moment. And then I've got people who are just staring blankly out at space. I just wondered if you don't have that, why? I mean, because tomorrow it's just going to be that times that. FOIL again, I'm sure.
I have a question.
Sage.
How come it's plus and not minus?
For which one?
Plus 5x.
Well, because this is positive 3 times 2 is a positive 6. Negative 1 times a negative x is a negative 1. If you have 6 x's and you take 1 x away, you're still 5 to the good. Unless I wrote something down. Which happens on occasion. John Dyer.
Are we allowed to like check our answer with the calculator?
No. You told me one that where the multiplication or whatever is hard enough that you need a calculator now.
No,
Okay.
but we want to check it just in case.
Check without the calculator. Jackson?
For number 17, the answer is 3 and negative 3, and I just put the square root of 9.
Right, well, you see, that square root of 9 is okay, but it's not simplified. If there is a square root of 9 and it can be simplified, you need to write that down. It's like not reducing a fraction.
So I have to.
Yes. If you can simplify the answer, you always write it in its most simplest sort of terms. Shellhammer?
Yeah, have again, I didn't understand. I don't get-
10 again. Alright, we'll give that another shot. Here's the deal. The model scale is 1 to 10. That means if it was 1 inch on the model, it would be 10 inches on the real thing. So what's the scale factor? What do you multiply the small one by to get to the big one? 10. So we are talking a scale factor of 10, but now we're talking about its volume. So anytime you talk about volume with regards to scale factor, you have to take that scale factor and you have to cube it. So you have to take that 10 and cube it, and that's where 1,000 comes from. 10 times 10 times 10 is 1,000, which means whatever the model is, you have to multiply by 1,000 for the volume of the new one. It's 1,000 times bigger volume-wise. So we knew that this thing had a, this time we didn't know what the model was, we knew what the actual thing was. The actual thing was this. So you have to go backwards from multiplying by 1,000 to dividing by 1,000, because it's going to get reduced by 1,000 times. So that's where the division, which is nice to divide by 1,000 because you just move decimals, Emma Haynes.
How did you do problem 6?
Well, I haven't done problem 6 yet, but I'm sure I'll get to it. Yes, 6 is not as bad as you would like, and here again, this is gonna boil down to you just jotting some notes down. Anytime you are asked for probability with regards to the areas of shapes, it's nothing more than doing this. You make a fraction. Okay, the probability of hitting the circle inside the rectangle is, you want to hit the circle, so it's the area of the circle over the whole area of the whole thing, which is that rectangle. It's the area of the circle over the area of the rectangle. The nice thing is they say you can leave your answer in terms of pi. So the area of a circle is pi times radius times radius. How nice that works. And the area of the rectangle is length times width. So what is the radius? Who asked me this one? What's the radius up here, hands? 5. So on top we end up with 25 pi's. And on the bottom, the area of the rectangle is length times width. 20 times 15 is 300. And that's where if you just reduce this is your area, it just needs to be reduced. 25 goes into 25 once, 25 goes into 300 12 times. And that's where pi over 12 is an answer. They've given us a number of those. The probabilities and areas, just the small one over the big one there. Tomorrow's, I'm going to guess, is going to be very similar. Oh yes, it is. Just a little bit different. Much the same, just a little bit different. Nathaniel.
When you do number 1, how long are
I will be number 1. Why is that? Is that number 1? Nathaniel, did you draw the picture? Oh, based on the word there, I'm gonna guess not. You don't have to draw pictures, only if you want to get it right. Let's do it here. Nathaniel, take a look, see. Let's see if we can come up with something here. Alright, Gloria went how far?
120 miles.
And how long did it take her? She went 120 miles
60 miles
at 60 mph. So how long would it take her to do that 120 mile trip?
2 hours.
So 2 hours. She came back that same 120 miles, but this time she was going 40 miles per hour. How long would that take you, Daniel?
3 hours.
3 hours. Now the average for the total trip is total miles over total hours. How many total miles should she go? 120 miles there, 120 miles back is 240 total miles, and what was her total time? 5 hours. If you divide 240 by 5, you get 48 miles per hour. You just can't take the average of 40 and 60 and say it's 50. Okay, you can't do that. You got to do total over total. We talked about that. It's just that way it goes. Or? Yes. We will resume fair discussion at the end of the day for any of those that we still have. Could it be part 3?
Yay! To be continued.
I can't get to the camera. It's going to keep recording forever.
Yay! Hi, camera.
Can I give a shout out to my mom?
Nick wants to thank all the little people that helped him get to 8th grade.
I like
I thought you were.
I was not talking to you for it. Shut.
Look at
that child.
Pretty sure.
Yeah.
Oh, no, 6. I did all this stuff, and you got piles 12. Well, I got piles 15. So I did 2 for 11.
I'm here for you, Jeff. You know, I remember these kind of sitting